Can I be in your video?
Alrighty, my name is Dominic Zolo. I'm doing the creature feature here. So for my research project, I chose the cone snail. As you can see, the nice scientific picture on the right. So I chose the cone snail because the venom that they use to catch their prey, we are developing medicines, and it can be used as a painkiller. So let's get started. Alright, just a few basic things before we get into the more scientific part. So there's over 800 identified cone snails, which is very diverse. Shells range from microscopic to as large as 10 inches when they're fully matured. As the snail grows, obviously it builds upon its patterned shell, making it larger and larger. The shells of the cone snail are bright in color usually and commonly collected and used for jewelry, which is bad for their species, but we'll get to that later. So they're also poisonous, and they have poisonous harpoons for predation and defense, which is the main point of this presentation, how we're going to be able to use that later on. And of course, they're slow moving. As you probably guessed, since this is tropical marine ecology, I chose a species that's found in tropical waters. More mainly, they're found in Red Sea, Caribbean, the Indian Ocean, as well as the Pacific. So whereabouts, they're found mostly in intertidal zones, although they can get at deeper depths. And they also live on sand, rocks, and coral reefs, and pretty much anything else. Okay, so the cone snail has a few interesting diet habits. First off, it's a carnivorous predator, and which hunts primarily at night, so that's kind of neat. Its diet usually consists of marine worms, small fish, mollusks, and even other cone snails. So in order to get their food, they use a siphon, which provides a sensitive method of locating the prey. After the prey is located, they use a venomous harpoon called a toxoglossum radula. So after they've located the prey and they have the harpoon, they can launch it through powerful muscular contractions. After the prey is stuck, then they retract the harpoon into the mouth to consume the animal. Then you can digest the bones, scales, and the disposable harpoon are regurgitated. Okay, so now that we've gone over the attacking and hunting methods of the cone snail, we can go into a little bit of depth of the defense. So they use the same venomous harpoons for attacking as they do defense. We'll go a little bit more into the harpoons. The harpoons are hollow and barbed teeth made up of chitin, and they form inside the mouth of the snail. So the effects on like a human, a small cone snail feels about like the pain of a bee sting. So it still hurts, but it's not gonna kill you, unless you're allergic. So, but however, the large cone snails, death within hours or less. So, I mean, obviously, as it matures, the sting becomes more lethal, and yeah. So, due to the wide range of molecular targets and variation in venom, each like cone snail species, it is virtually impossible to create an effective anti-venom for all of them. Alright, so now we can move on to the cone snail venom, which we want to focus on here in the presentation. They obviously, as we've learned, they use it for hunting and protection. So the actual venom itself contains a complex mixture that includes neurotoxins, which are chemicals that block the conduction of nerve impulses, which in turn will leave prey or predators paralyzed. A little scary fact, the venom from one large cone snail has the hypothesized potential of killing up to 700 people with one dose. So although one dosage of this cone snail venom can kill up to like 700 people, we're finding ways, obviously, to lower the dosage and use them in real life. So, first of all, we found a conotoxin from species C. magnus that has been FDA approved for chronic pain management under the strain name Prylat. So, Prylat we'll be taking a deeper look at. It's one of the main pain medications that we're getting from this venom that has great potentials. There's also like a few lesser things, like we made an anti-wrinkle cream from the venom. it lowers the inflammation in skin and puffing out creases and fine lines on human faces. Other toxins have also been considered as management of Parkinson's disease, which is pretty cool, and provide cardioprotective effects. Alright, so let's dive deeper into Prylat, the pain medication that we're getting from this cone snail venom. So first off, it's an incredibly powerful painkiller that people are using when morphine no longer works, usually like chronic cases. So the big issue with Prylat is with the blood-brain barrier. So the blood-brain barrier is a kind of membrane that prevents most compounds in the blood from entering the brain. So in many ways, the layer is protection and is actually helpful to us, obviously. But if Prylat doesn't get to the brain, it can't ease the pain, so it's kind of pointless. So currently, the drug can only be administered through an injection directly into the spinal column. So with that being said, it's not really convenient for patients or doctors yet, because first it's tough to administer, and then obviously it's a lot of money and uncomfortable for the patients. So we're still trying to develop ways to make it a lot easier. So I added a picture of Prylat in. It just looks like a clear liquid. It's not too exciting, but right above that you can see the structure, and then on the right I added a little diagram in to show you the spine and the brain. I know you know where the spine is, but how it attaches to the brain. So that blood-brain barrier isn't actually a factor if you inject it right into the spine. So in order to inject the venom into the spine, experts and doctors use a intrathecal pump, and then that will lead it right to the brain, which in turn will ease the pain. Alright, so all that we've talked about so far with Prylat is what's currently available. We are able to administer it through the spine, which is proven to ease the pain. So for the future, which is really important because, like I said before, it's not really made for the doctors or the patients. It's tough to use right now, but in the future and currently, scientists are experimenting on how to administer the drug more conveniently. That results in the same effect. So this would be huge for the medical department. So what they've been doing so far is putting the peptide inside of a carrier called a viro nanocontainer. And the nanocontainer is a tiny receptacle made from proteins found in viruses. So in doing that, the Prylat can be shuttled across the blood-brain barrier using another cell-penetrating peptide. And so tests conducted have proven effective, meaning that we may be able to inject the drug straight into the bloodstream, or even through the use of a pill later on in the future. So that would be huge. Alright, so just a few more things in conclusion to the venom's significance. So first off, Prylat is 1,000 times more powerful than morphine, but is not believed to be addictive. So that could be huge in the industry, as we're suffering from that epidemic right now of people addicted to painkillers. So if it's not addictive, that could be absolutely massive in the field. It's hoped that the drugs will eventually reduce reliance on highly addictive opioids. So that's kind of what I just went over there. But unlike other pain medications, the venom has the potential to provide long-lasting relief. So that could be a nice change-up. So instead, of taking morphine every 6-8 hours, you'd be able to take this venom for a lot larger periods of times with one dose. And then I added in a quote from expert McDonald Christie. He said, "Early indications are that the conotoxins are more effective than both opioids and cannabinoids, may have fewer side effects, and the additional benefit of treating the cause of pain."